All the planets in the solar system are aligned along a plane that is nearly flat. Although this line can't be seen with the naked eye, it becomes apparent if you carefully track the paths of the planets throughout the night. This is known as the ecliptic plane, and this plane is not random. It reflects a pattern of orderly, predictable motion. The ecliptic plane is defined as the orbital plane of Earth around the Sun. In other words, if you imagine the Sun at the center and draw an imaginary flat surface following Earth's orbit, the orbits of the other planets generally stay close to that same plane. But the word generally is key here. That's because each planet's orbit is tilted slightly, by a few degrees, relative to the ecliptic. For example, Venus orbits with a tilt of about 3.4 degrees, while Mercury's tilt reaches up to 7 degrees. These small differences are what cause the planets to appear slightly off the same line in the sky. In addition to these tilt differences, each planet also takes a different amount of time to orbit the Sun. While Earth completes its orbit in 365 days, Jupiter takes about 12 years, and Neptune takes 165 years. Because of these varying orbital periods, the positions of the planets in the sky are always changing, each one moving at its own pace. Some return to the same spot relatively quickly, while others may take centuries to realign. In addition to all of this, there's also a difference between how we see the planets in the sky and where they actually are in space. That's because the sky is a two-dimensional projection of a three-dimensional structure. From Earth's perspective, the planets may appear to line up along the same path, but in reality they are separated by millions of miles in space. In such calculations, scientists make an important distinction: absolute alignment versus sky alignment. Absolute alignment refers to a theoretical condition in which all planets fall along the same straight line without any angular deviation, a situation that can never actually be observed. Sky alignment, on the other hand, refers to how the planets appear to be arranged in a specific direction from Earth's viewpoint. This visual alignment is typically considered valid if the planets fall within an arc of about 30 to 40 degrees. So, can all the planets ever truly fall into a single straight line? The answer is no, because the architecture of the solar system doesn't allow for it. Each planet not only moves at a different speed and takes a different amount of time to orbit the Sun, but it also follows an orbit with its own distinct tilt. Yes, these tilts deviate from the ecliptic plane by only a few degrees, but even small angular differences create major spatial separations across billions of miles. For instance, Earth's orbit defines the ecliptic plane, but Mercury moves with a tilt of about 7 degrees relative to it, and Pluto can reach up to 17 degrees. Other planets follow similar paths with small but significant deviations. These differences mean that the planets in space will never be arranged perfectly on the same plane. In other words, even if you were to draw a line with the Sun at its center, it would be physically impossible to see all the planets lined up along that line at the same time. Forcing a three-dimensional structure into a two-dimensional alignment simply ignores the planet's true spatial positions. However, from Earth's perspective, there are times when several planets appear to be positioned near the same line in the sky. These visual alignments are really just two-dimensional projections that exist only from our point of view. So how often do these visual alignments actually happen? Because each planet moves at a different orbital speed, their motion across the sky isn't regular. It follows periodic fluctuations. This makes some alignments extremely rare, while others happen more often. For example, it's fairly common to see three planets appear along the same general line in the sky. Events like this can happen several times a year. Inner planets like Mercury, Venus, and Mars play a frequent role in these alignments because of their shorter orbital periods. But when a fourth planet joins the line, the odds drop significantly. Four-planet alignments typically occur once every 2 to 3 years, while seeing 5 planets aligned at the same time is a much rarer event, happening only once every 10 to 20 years. Alignments involving 6 planets gathering in the same region of the sky are truly exceptional. On average, these occur only once every 50 to 100 years, rare enough that you might witness just 1 or 2 of them in a lifetime. And even when they do occur, not all the planets can be seen with the naked eye. Outer planets like Uranus and Neptune are too dim to observe without a telescope, setting a natural limit on what's visible during these events. The alignment of 7 or even all 8 planets in the same region of the sky is considered even more extraordinary. Historical records and astronomical simulations show that alignments of this scale occur only once every 300 to 1,000 years on average. One of the last major alignments where all 8 planets gathered within a specific angular range happened in the year 949. The next one isn't expected until 2492. So, will we see anything like this anytime soon? The answer is surprisingly clear and exciting for skywatchers. On the morning of August 10, 2025, a rare planetary alignment is set to take place. But this event won't be limited to just a lineup of planets. During the same early morning hours, a meteor shower will reach its peak, and a close conjunction between 2 bright planets will also occur. The statistical rarity of all 3 events overlapping makes this a truly exceptional moment in the sky. The core of the alignment will include 6 planets: Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune. The ideal viewing time will be about an hour before sunrise. That means between 1:30 and 2:30 a.m. UTC on August 10th. If you look toward the east-southeast horizon, you'll be able to see most of these planets lined up in a visually striking formation. Of course, Uranus and Neptune will be too faint to observe without a telescope, but their positions in the lineup have been confirmed through astronomical calculations. Venus and Jupiter will be the true standouts of the event. That same morning, these 2 planets will appear extremely close to each other, almost touching when seen from Earth. This kind of visual pairing is called a conjunction, and it typically happens a few times a year. But a conjunction between 2 of the brightest planets in the sky is both easy to observe and visually stunning. This one will briefly shine during twilight before fading from view as the sun begins to rise. Another factor that makes this night so special is the Perseid meteor shower reaching its peak. The Perseids, which appear every year from late July to mid-August, are caused when Earth passes through a trail of debris left behind by Comet Swift-Tuttle. In 2025, this meteor shower will hit its maximum intensity on the very night of August 10th. So during the hours of planetary alignment, viewers will also witness one of the most spectacular meteor showers of the year. Even better, the moon that night will be in a thin phase, just enough to reduce sky brightness and create ideal viewing conditions. And just 6 months later, another alignment will occur. This time, however, it won't take place in the early morning, but shortly after sunset. On the evening of February 28, 2026, the western sky will once again host a planetary gathering, this time featuring Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune. Evening alignments like this are much rarer than their morning counterparts. After sunset, planets take time to climb high enough in the sky, and those near the horizon can be difficult to see. But in this case, the situation is different. All 6 planets will appear in the western sky within a short window of time, forming a near-line configuration that lasts about 40 minutes. The best time to view this alignment will be between 3:30 and 4:15 p.m. UTC. In this lineup, Venus will again be the brightest object in the sky, shining prominently just after sunset. Jupiter and Saturn will follow. Mercury, sitting very close to the horizon, will be visible for only a short period. Uranus and Neptune, though faint, can still be spotted using small telescopes from locations with low light pollution. This alignment also has another advantage over the morning examples. It happens during hours when people are actually awake and active. While observing the sky at 5 a.m. usually requires special planning, an early evening alignment like this offers a much more accessible opportunity. That's why the February 2026 event is likely to draw interest not just from astronomy enthusiasts, but from a much broader audience. But these celestial gatherings won't be the only surprises the sky has in store that year. On the morning of April 18, 2026, just as the first light of dawn begins to appear, another smaller but visually striking alignment will occur. This time, only 4 planets will be involved: Saturn, Mars, Mercury, and Neptune. Despite having fewer planets, this alignment will be quite compelling from an observational perspective. That's because smaller alignments often happen within much tighter angular distances, making the planets appear very close together in the sky. This allows them to be captured within a single telescope frame or a wide-angle camera shot. But that advantage comes with a challenge. Since this April alignment takes place in the early morning, the planets will be visible for only a very short window just before sunrise. For Mercury and Neptune, both either close to the horizon or relatively dim, spotting them will require perfect timing during the darkest phase of twilight. That means just a few minutes of precise observation. In this lineup, Mars will be the easiest to spot. Thanks to its brightness and moderate altitude, it should be clearly visible to the naked eye. Just beside it, Saturn will appear as a dimmer but noticeable point of light. Mercury, being closest to the horizon, will disappear quickly. Neptune, as always, will require binoculars or a small telescope to be seen. While the gathering of multiple planets in the same region of the sky is already a special event, the involvement of the Moon in these alignments adds an entirely new level of visual richness. The Moon isn't just a passive bystander. It often joins these celestial lineups and, at times, even hides them from view. These events are called conjunctions by astronomers and refer to the apparent close approach of two or more celestial bodies in the sky. One such example occurred in January 2025, during the conjunction of Venus and Saturn. As both planets appeared to draw closer in the morning sky, the thin crescent moon joined the alignment, creating a striking visual. 2 months later, in March 2025, an even rarer phenomenon was observed. The moon temporarily covered Mars. In astronomy, this is known as a lunar occultation, an event in which the moon passes in front of a planet from Earth's point of view, briefly making it disappear. Mars's bright red glow faded suddenly behind the moon's dim gray surface, only to re-emerge moments later. Later in the year and still ahead, more symmetrical and visually pleasing conjunctions have taken place, or are expected to. In April, the Moon, Venus, and Neptune formed a narrow triangle in the sky. In September, Venus will align with Regulus, a bright star, and the Moon will pass just below this pairing. In areas with low light pollution, these configurations may even resemble a smiling face in the sky. So what will happen in the year 2492 when all the planets in the solar system are aligned? When all the planets align in the same direction, their gravitational forces technically concentrate along a single axis. However, this combined pull is not significant enough to have any measurable effect on a star as massive as the Sun. For example, Jupiter, the largest planet in the solar system, still has only about 1,000th the mass of the Sun. Even if every planet aligned at once, the total gravitational effect on the Sun would not be enough to alter its internal dynamics or motion. In other words, the Sun is far too massive to notice the alignment of its planets. Moreover, there is no direct link between planetary alignments and solar activity, such as eruptions. Solar storms, also known as coronal mass ejections, originate from internal imbalances in the Sun's magnetic field. These explosive events are tied to the Sun's own internal structure and cycles and are unaffected by external gravitational forces. While some theoretical studies have suggested that large planets like Jupiter could contribute to long-term solar magnetic cycles through tidal influences, the effect is extremely weak and not nearly strong enough to trigger solar storms directly. Planetary alignment also does not generate major physical effects on the other planets. However, there is one partial exception: Saturn's rings. These structures are highly sensitive to gravitational changes from external sources. Even so, the gravitational influence caused by a planetary alignment is far too weak to cause any noticeable disruption in Saturn's ring system. So what about Earth? Claims that a major planetary alignment could trigger geological events on Earth are not supported by scientific evidence. That's because the primary celestial bodies responsible for Earth's tides are the Moon and the Sun. Their gravitational influence on Earth is vastly greater than that of all the other planets combined. For example, the tidal force exerted by Jupiter or Saturn on Earth is only about 1/millionth of that caused by the Moon. So even if several planets align, this alignment has no measurable impact on ocean behavior or tectonic stress within Earth's crust. Despite popular beliefs that such alignments might lead to massive earthquakes, no scientific study has ever confirmed such a connection. The same holds true for Earth's rotation speed, magnetic field, or seismic activity. No detectable anomalies or increases have ever been observed in these parameters during planetary alignments. Throughout history, planetary alignments have left a deep impact not only on the sky, but also on the human mind. From ancient civilizations to the modern day, many cultures have attributed mystical meanings to such celestial events, interpreting them as signs of prophecy or omens of an approaching end. As the year 2492 approaches, it's likely that a similar wave of speculation will reemerge. For some, the moment when all planets line up may symbolize a great awakening, while for others it could represent a cosmic catastrophe. The media, social platforms, and pop culture may circulate exaggerated claims, documentaries, or fictional scenarios surrounding the event. Themes like the beginning of a new era, signals from beyond, or collective consciousness shifts could resurface as that date draws near. But the solar system has experienced such alignments before, without any disasters. So this rare visual spectacle carries only symbolic and observational value. It may be exciting to witness, but that excitement stems from the scientific elegance of a predictable universe, not from chance or prophecy.